All right, B's and G's, welcome back to the DT. Hope everyone's having a WD. The drive-thru is sponsored by the deli. Hungry? Stop by the deli. Get yourself some roasted cashews, salted, courtesy of the wonderful Mr. Pletz. Okay, this is the best proof we've done all year to this point. 2.6, number 11. I'm going to try to do a great job explaining this to you. We are given that SZ is congruent to ST, so we know that these two segments are congruent to each other. Okay? We also know that XY is congruent to WV. Okay? And then we know that V and Y are midpoints. Now, look what we have here. We have two statements involving midpoints. In your notes yesterday, you learned that if you see the word midpoint, bisect, or trisect used more than once, then you should anticipate that you're going to use a multiplication or a division theorem. So, let me start out by using this fact. So since V is the midpoint of TW, and Y is the midpoint of ZX, and since we know that VW equals YX, then we know that ZX is congruent to TW. All right, now let's think about why that is. If two segments are divided and are congruent to each other, then their original segments must also be congruent together. So, another way to put this is that we've gone from two small congruent segments to, let's use a highlighter here. Now we have two big congruent segments, and so since we've gotten bigger, this is segments multiplication theorem. Some of you might say, is that a property? Yes, it's both. So you can put a segments multiplication theorem or segments multiplication property. Now, look what we have. We have that ZX is congruent to TW. We have that SZ is congruent to ST. We are trying to prove that SX is congruent to SW. So look, we've got this part is congruent to this part. That part is congruent to that part. Do we know that Z or T are midpoints? We do not, so this is not segment multiplication. We know that SX is congruent to SW, okay, by segment addition. Sorry, segments addition theorem.